Okay then guys, just a little intro to get you started on this section of loci and regions. Let's have a look at this then. So let's just do a few plots. Let's take z is equal to 2. So the modulus of z, so take a complex number whose modulus of z equals 2. Basically this corresponds in terms of its loci, which maps out the points that it moves around, satisfying this condition. We can go around at 2, can't we? So any z number that on this circle here, any of those has a value 2. Anything off this circle has a modulus less than 2 or greater than 2. So this is the loci then, given by this condition here. So that's z equals 2. Suppose we had z is less than or equal to 2 then now, and we'll do a region. So if we did z less than or equal to 2, so let's do that here. So what about z less than or equal to 2 then? Well, again, we want to draw the circle. So I better just do undo. There we go. And we're going to do less than or equal to 2 now. And basically that would denote that region would be any z number that has a modulus less than or equal to 2. So again, that's the whole of that segment, the whole of the circle, solid circle here, this disk. Any z number in here, if you took its modulus, it would be smaller than 2. It can also equal 2, if you'll notice it here, so it can touch. So that's why this boundary is denoted by a solid line. Had it been just less than, so let's just mark off that now. Suppose we had less than. Well, we want to denote that the actual boundary isn't touched, don't we? And the customary way to do that is to simply let's just get rid of these if I can, carefully. So let's do z is less than 2 now. So we'll draw the same circle, but this time we're going to do a dashed circle, and a dashed circle simply denotes that the boundary is not included in the set that we're considering. So z is less than 2 would be this region here inside. So you would shade that region. If you were shading the region z is greater than 2 on the other hand, which would be like so, then any point out here has a modulus distance away from 0 greater than 2. So it's the whole of this region, and you would shade it customarily like so, with slanted lines denoting that all this region is included in the shading. So there we are. It's a dashed line because it's greater than. Had it been greater than or equal to, then we would have then infilled the dashes to denote that the line in question, the boundary here, was included in the region. So points can actually lie on this line as such. So that's the gist of it. The other thing that we could think about would be arg z. If we have an arg z, that's the angle of the z number, the principal angle. Suppose it's less than pi over 3 and greater than or equal to pi over 4, say. Let's just look at that then. And we'll do a little sketch for this one. Again, this is going to be a region. The angle of the z numbers have to be between two values. Pi over 4 is 45 degrees. So we can draw out two lines from the origin here, can't we? So let's do that then. So we'll draw out one at pi over 4, which is 45 degrees. And then we'll do another one. And these lines continue out at, say, 60 degrees. Now, the region in between is the region in question. But there's a point to mention here, is that this one is the arg z is greater than or equal to, so anything above this angle and including points with this argument are included. But on this side, basically we go up to but we don't touch. So this line would not be correct to do. We need to replace it by a dashed line. So let's put in a dashed line then. Here, a straight line, if hopefully that's reasonably okay for you to get the gist of it. So if we shade off this region now with the slanted lines to denote that this region is the said region. So given by this condition. So that's basically the gist of it. Most of the problems are variations on the same themes as these sort of problems. There can be some sort of complicated problems. Sometimes we might need to use polar coordinates. Sometimes it's more convenient to use Cartesian coordinates. depending on the question. And if one seems rather awkward, then we just simply try the other approach. So all the best then, guys, for this section, and I'll catch you again in another live worksheet. Cheers!